Hi, this is a video about a moments question coming from sort of an exam question. So, a uniform bookshelf AB has length 1.2 meters and mass 6 kilograms. It's supported with light inextensible vertical strings, so here they are, attached at each end. A stack of identical books, each with a mass of 1.5 kilograms, is placed on the bookshelf as shown in the diagram. Either the strings will break if the tension exceeds 80 newtons. So modelling the books as a particle, find the greatest number of books that can be placed at the centre of the bookshelf without breaking the strings. Find an expression for the moment about A of the weight of n books when the stack is a distance of x meters from A. State the units for the answer and calculate the greatest distance from A. The largest stack of books can be placed without the string breaking. Okay, like as all mechanics diagrams, it is a good idea to start with drawing a diagram. Try to draw the diagram as large as possible and make it clear. Okay, so what forces do we have acting on our bookshelf? Well, we have one string here acting upwards of maximum tension of 80 newtons. We have another one here. Now, because the beam is, or the shelf is uniform, at the centre here will be the weight of the plank, so it's 6 kilograms, so the weight will be 6g newtons, and then we've got a number of books here, and their total weight will be 1.5 times the n, which is the number of books, g newtons. Okay, so because we will eventually need to find the value of n. Okay, so if we now resolve vertically, so what we've got going upwards, we've got 2 times 80, and then downwards we've got 6g, so we've got to take away 6g, and then we've got to take away minus 1.5 ng, and because it's all in equilibrium, that will be equal to 0. So this is just at the point of breaking, that is. Right, so we now formed an equation, and like in all mechanics problems, the next thing you would do is to solve that equation. So that will give 1.5 ng is going to be equal to 160, 2 times 80 minus 6g, and then that will give you the n is equal to 160 minus 6g over 1.5g. That will give you 6.884. So you can't have 7 books, because that will break. Okay, so we'll have to take round down in this case. So the maximum we can have is 6 books. Okay, next it says find the moment of these books about a point A. So if we let the distance from A to the books be x, okay, so it was going to make, if we're taking moments from A, it's going to make it go around this way. So this is a clockwise moment. So the moments from A for the stack of n books is going to be equal to 1.5 ng, which is the total weight, x. Okay, now officially it should be negative because it is a clockwise moment. Okay, and you're asked to state the units, so the units will be Newton meters. Okay, so now we want to find the position of x. So we know this is x. So adding in some other distances, this distance here will be 0.5 meters because it's uniform. The centre of mass will act at the centre of the shelf. Okay, and the total length of the shelf is 1.2 meters. So we're taking moments about A, so we can ignore this force here because there's no distance. And so making it go anti-clockwise will be this one here, which will be 80 newtons times 1.2. So taking moments about A. So I'll just repeat, we're going to have to bother with this force here. And we have to put 80 in because that's going to be the maximum tension allowed. That's going to be times 1.2. Going the other way, we're going to have 6g times 0.6, 6g times 0.6. And then we're going to have 1.5g times 6. Now it's 6 because we've just worked out 6 is the maximum books would be allowed, times x, which is what we actually got to find. So what we've got to actually find is this distance here. So we formed our equation, so now we'll just need to solve it. So that gives me 1.g times 6x from here. It's going to be equal to 80 times 1.2 minus 6g times 0.6. So going up here, we're going to have that x is going to be 80 times 1.2 minus 6g times 0.6 divided by 1.6g times 6, and that will give me 0.6884. A normal practice is to round off to 3 significant figures, so that will give me 0.688 meters. So this distance here will be 0.688 meters. So this has been a video to show you how to find the number of books in a stack on a bookshelf, and using moments to find the distance where you need to place the books. I hope you've understood, and I thank you very much for watching. And if you can consider subscribing to my channel, that would be great. And I will see you in the next video. Thank you very much.